Good day. Today we're gonna look at maths, simultaneous equations specifically. So when it comes to simultaneous equations, we have to calculate the value of x and the value of y on these two equations that we given here. So this is not your traditional equations whereby, for instance, you have x plus 2 equals to 4, whereby the only thing that you have to calculate is the value of x. In this case, you also have a value of y, which is 2. That's why we call it simultaneous, because there's two of the values that needs to be calculated on these both equations that we given here. So for instance, in this traditional way, we've got this member 1, we've got this member 2. So in this case, we just say x equals to 4. This is adding this side is gonna minus. So our value of x is equals to 2. So this is just a traditional way to resolve our equations. But when it comes to simultaneous equation, is a little bit tricky and a little bit different. So the first method we're gonna use the method of substitution to calculate our equation. So let's just quickly remove there we go. We'll delete this. Okay. All right, so we're gonna start resolving using the method of, we call this method the method of substitution. This is the method of substitution. So the method of substitution, we choose between this equation or that equation to make x or y the subject of the formula. How do we make x or y subject the formula? So meaning that we choose between x and y the subject of the formula. Which one is easier for us to make the subject of the formula, whether x or y? In this case, when I look at it, y is easier to be the subject of the formula. So let's get into it. So we've got the first equation for x plus y, it's equals to 17. How do we make y the subject of the formula? Y it's equals to 17 minus 4x. So the value of y is this value that we have down here. So we go to the second equation, which is this one here. We take this value of y, we substitute where there's y. How do we do this? We take 2x plus, what's the value of y? 17 minus 4x. This is our value of y that we have here, which is equals to 9, right? In this case, now we've got x here, so it's easy to actually resolve this now. In fact, we don't really need to put the brackets. There was no need to actually put the brackets. I was just putting it between brackets just to try and explain that our y value is equals to 17 minus 4x. So let's go and resolve this. This type of equation now is on a format of our traditional equation, which is now we don't have x and y here, we only have y. So x and x can be added. Let's go into it. 2x minus 4x plus 17. We're just organizing it basically now, equals to 9. All right, and then 2x minus 4x, we've got minus 2x, which it's equals to here's 9. Okay, so minus 2 plus 2 minus 4, we're gonna have minus 2x, and then we have 17 here. We can actually say equals to 9. 17 is positive. When it goes to the other side, becomes negative. So what are we gonna have? We're gonna have minus 2x. This side is equals to minus 9 minus 17. We're gonna have minus 8, and then minus 2x. Both sides is negative. What can we do to change this? In a normal way, we multiply everything times -1. How do we do this now? We're going to have 2x equals to 8. Both sides now is positive, so we can actually say x is equals to 8 divided by 2. It was multiplying, now it's dividing. So our value of x is equals to 4. And then we go back to our first equation here. We substitute now the value of x. What is our value of x? Our value of x is equals to 4. So meaning that where there's x here, we put 4. What do we get? We get y equals to 17 minus 4 times minus 4, yes, times 4. We're gonna 4 times 4. 4 times 4, yes. So 4 times 4 here, we're gonna get our 16 minus our 17, which means our value of y, 17 minus 16, it's equals to what? It's equals to 1. So we go back to our answer through the method of substitution. Our value of y is equals to 1. Our value of x is equals to 4. So basically, now we've managed to calculate the value of y, and then we've managed to calculate the value of x. So that's how we do using the method of substitution. And just to break it down again, all the steps, we firstly chose to make x or y the subject of the formula, and then we decided to use y because y was easier to make it the subject of the formula. As soon as you do that, which is this part here, and then we go to the second equation because we used the first equation to make y the subject of the formula, and then we went to our second equation to substitute the value of y on the second equation. Where there's y, we put this value here after we made y the subject of the formula, which is 17 minus 4x. And then we took our second equation, which is right here. From there, we just substituted the value of y, and then we had x and x, which made everything easier. Thereafter, everything is just easy. You get the value of x, and then you come here, you substitute again here the value of x with 4, which we did say here, 4 times 4, right? Which we got our 16 there, and then that's it. We got the value of y, which is 1. That's it. In most cases, it's always good when you've resolved a simultaneous equation like this, you do proof to ensure that the answer is actually correct. How do we do that? We go back to our original formula. We go back to our original equations back here. This one here and that one. So we've got a value of y, which is equals to 1, and then our value of x here, which is equals to 4. So we substitute the value of x, which is 4, and the value of y, which is 1. How do we do this? We say, so when we substitute that, it must be equals to 17. If it's not equals to 17, which means our answer is incorrect, right? Let's do that. 4 times 4 plus 1, it's equals to 4 times 4 is 16 plus 1, it's 17. So which means it's correct. Let's go to the second equation. 2 times x, which is 4, right, plus y, which is 1. So meaning that these times these must be equal to 9. 2 times 4 is 8 plus 1 is 9. So definitely our equation is correct. So we can move forward knowing that our equation is actually correct. So that's how you do a proof for your simultaneous equation after you have resolved the value of x as well as if you have resolved the value of y. Thank you.